So it should be recording, and I'll go ahead and share the screen. If you have any questions as we go through, don't hesitate to ask anything. I think
Sure.
you probably see it. Let me see if it did share. So do you see that up there? Okay.
Your screen hasn't come up yet. Hold
Okay.
on.
Maybe I clicked it twice. I can try it again. Okay, I'll try it again.
Yes, I can see it.
You can see it. Okay. So we'll go ahead and do it. And like I said, this is right down here on algebra topics. And there's 30 questions total. So this is pretty long assignment. The practice test has about 35 questions on it. The test, I forget how many it has. And then the final assignment, the practice test, is pretty long. It's like 55 questions or so. So, they do take a little while to get through them. So let's go ahead and do this. And now, go ahead.
For the final homework test.
Let me see what it says here. Yeah, let's go down here and see. It may be unlimited time for that. So if I go down here to algebra and I open it up and I look at the, let's open that up right here. I think it's in this area. And so we got right here, the final. It says this homework assignment is extremely similar to the actual practice test, has 55 questions on it. You have unlimited attempts and no time limit. So no time limit on that.
Right, I read that before. Yes.
Okay.
Right.
But it says comparison to the actual praxis test, it has 56 problems, and you do have a time limit of 80 minutes on the actual praxis. And so it tells you everything about the actual praxis right there. But okay. And the test, though, before that praxis thing, the very last assignment, there's a test, and that test is just a regular test. That's 2 hours, and it has 30 questions on it. Yeah, so that's it on that. Okay, so let's go ahead. I'll just click on it up here, the algebra thing, the algebra homework thing. Let's go ahead and do it. And I'll put it in teacher preview so we can check our answers and stuff as we go. And we are recording, so we're okay. Now, on this, I hit some algebra problems that we had earlier in the semester that aren't too hard, but then by about problem 10, and there's 30 on here, by problem 10 or so, we're into stuff that is getting pretty tough. So I'll just go through these so we can get used to it. So on problem 1, probably not all these you would need to see, but it doesn't hurt to talk about them. So on problem 1, yeah, it doesn't hurt at all, I guess, to talk about them. So environmentalists are trying to estimate the size of a fish population in a small lake. Using nets, they catch 35 fish. So they have 35 fish. And they tag them. So these 35 fish are tagged. They put like a tag in their gill. And then 3 months later, they catch 175 fish. And this is really how they do this. They get an estimate for how many fish are in the lake. And they find that 20 of them are tagged. So 20 out of the 175 are tagged. So the way you do this is setting up a proportion of sample tagged to sample amount of fish. I'll show you. So for example, in this lake, they think using this right here, they sampled out 175 fish and 20 were tagged. That's a little proportion we can get real quick. Now you might be saying, okay, so what do we do with this? Well, up here, this is the total amount of fish tagged. So there's 35 in the whole lake total tagged. And that should be the same proportion as here in terms of the total amount of fish. So here, this unknown is the total amount of fish in the lake. So this is a sample. So they sampled out 175 fish. In that sample, 20 were tagged. We know that the total amount of tagged fish is 35. So it should be the same proportion that tells me the total amount of fish. And that's the real thing. I got this from when I wrote this problem, I got it from one of these environmental magazines or, like Marin State Parks, and they said how they do it. But once you get the proportions set up, you just cross multiply. So 175 times 35 equals 20 times x. And then to solve it, you just divide through by the 20. So divide by 20 here, divide by 20 here, and boom. If you do this arithmetic right here, that's your answer. So that's how you do that one. I think it's still a tough proportion problem, but it is a proportion problem. And there's a lot of proportion problems on the Praxis.
Right. I saw your answer to Mugabe Bowden's question about they needed to do a proportion on the ages, and that the problem, it was an equation that, and the total ages added up to 70. But she needed, or he or she needed to do a proportion problem in order to solve that. I saw that.
Yeah, and I didn't answer him much on that one, I'll tell you that, because I mean, I need to see something. And so he didn't write very much. I said, you got to show, what are you trying on that? Yeah.
Right.
Yep, that's it. On that. So
it was pretty simple to figure out. I just think he went in the direction.
He might have gone the wrong direction or something. I don't know. But I get that all the time. People ask questions and they don't put, some people just click submit and they don't put anything. And like, I don't know what you need to show something here. So, yeah. So, okay. Well, anyway, so two, as of 2019, the year, this is another proportion problem. It's all this is. As of 2019, the yearly average birth rate in India was approximately 22 births per 1,000. So you can get that. See, 22 births, that's the ratio. I find this one to be more straightforward than the fish problem. 22 births per every 1,000 people. Determine the total number of births. So we don't know. I'll call that, I don't know how many X number of births. For India's population, and India is very, very high population. And it says 1.108 billion. Well, you have to get how many zeros that is. So that's 1,108,000,000. So the population of India is just gigantic. It's the second most populous country in the world. So the only thing tough with this one, in my opinion, is the icky numbers on this. And so it's the same type of thing. You would do this by cross multiplying. I would do that here. So here, I'll just draw the arrows here so you can see. We do like this. So you get this 1,108,000,000 times the 22 equals this 1,000x. And then you would divide both sides by the 1,000. Divide through by 1,000. And to save a little bit of error that you could make on what you can do is when you're dividing, you can cross out these zeros, like 3 zeros here with 3 zeros here, and that can save you a little bit of time. But anyway, just do that and you'll get your answer to the problem. All right. On 3, there's a lot of calculators that will do scientific notation, but you're only plenty of problems on the Praxis. You can't use any calculator, but when they do allow you to use a online, like an on-screen calculator, it only has 4 functions: addition, subtraction, multiplication, division. So you really can't do a problem like this, the scientific notation problem, on a calculator unless you know what scientific notation means. So I'll show you that here. So really big numbers and really small numbers are written in what's called scientific notation. And scientific notation always has a times 10 raised to some power, and it has a number between 1 and 10. It's a single digit number to the left of the decimal point and as many numbers as they want on the right hand side. So basically you find numbers between 1 and like 9.9 on the left hand side, and that's scientific notation. So when the exponent is negative, it's just a little, the best thing I can tell you here is just a little rule. When this exponent is negative, you move your decimal point to the left, how many places it says. So we're going to move it to the left 2 places. So this would be 1 place, and we got to move it to the left again. And that takes care of all that stuff. So this number is really 0.059. See, here's where the decimal point was, move it 2 places to the left. So that's what that number is. This number, since it's positive 2, you move the decimal point 2 places to the right. Here's 1 place, you'd have to move it 1 more. So that actually makes it 570. And at this point, just use a calculator because you're just multiplying 2 numbers together. So, just use calculator. So that's just known scientific notation, what it means.
Okay.
Comes up a lot in science courses. Here's one more. 4 is the same type of thing. I'll do it for practice. So the first number is 3.5 times 10 to the -3rd. It's always written times 10 to something because that means you just have to move the decimal point. That's all you got to do. 1.7 times 10 to the 8th. So here we go. This means move to the left 3 places. So that'd be 0.0035. Why? Well, here's 1 place. That puts it right here, then 2 more places, 2, 3 places. So that's what that number is. This 8 here means move it 8 places to the right. So that'd be 1, 7. See, here's 1 place to the right. That takes care of 1 of these places. Then we have 7 more places. 1, 2, 3, 4, 5, 6, 7. That's a really big number. Like it's 170 million or so. So then I would just do this on a calculator at this time to finish it off. And that's all you got to do. Not too bad. Those are ones you don't want to miss on the practice test because, if you know how to move a number in scientific notation, then boom, you got it. Okay, 5 says now you're getting to some algebra stuff a little bit here. So I would say right here, basically in problem 5, we're into algebra stuff. There may be a few algebra ones that we had in getting equations that come up, but most of these are new type of problems, so they get pretty rough. So you plan to rent a car for 1 day. A car rental company offers 2 plans for renting a car. Plan A, so let me write this down here. Plan A is this. It says $30 per day plus 17 cents a mile. So $30 plus 17 cents per each mile. So I'll just use the letter M for mile. In fact, I look down below here and it says use M for miles. So boom, that's what plan A is. See, like if he drives 10 miles, you just put 10 in for M and you can work it out and see how much they charge. Then it says plan B is this, it's $50 for the day and free unlimited miles. So the cost is just $50. That's it. So you can drive as much as you want. So now it says, what inequality represents the situation in which plan B saves you money compared to plan A? Well, if plan B saves you money, that means that plan B has to cost less than plan A. So that's the inequality we want. And we just fill in here what the different things are. Like plan B is this stuff, 50. That's all. And plan A is this stuff here, 30 plus 0.7 M. And that's really all you need to type into here. So like this is, so if you put this stuff on this side, so here, I'll show you. Oh, here it says use M to represent the number of miles the car is driven. Huh. Oh, it says, put plan right here. It says it. It says put the expression for plan A on the left. So the way to do this is if you want B to be less than A, that's the same as saying A has to be greater than B. You know what I mean?
Yes.
Yeah, plan A on, and put plan B on the right. So here's plan B. And it does say plan B saves you money. So in other words, B has to be less than A or A has to be greater than B. So that's why we needed this stuff, the 30 plus 0.7 on the left-hand side, and it needs to be greater than 50 on the right. So this, you'll see this says greater than, and this says 50. And then it says solve it. So what I would do to solve this, there's an M here with this, is I would subtract 30 from both sides. And if I do that, I get 0.7 m equals 20. Divide through by the 0.7 on both sides. And whatever you get when you do this division is going to be your answer right there. Like if I type in, well, you can't type it in, so you have to do it on a calculator. Take 20 divided by 0.7. And, oh, okay, so it's an inequality. I'll show you. When you do 20 divided by 0.7, let me make sure I'm doing this right.
Should be
0.17.
0.17.
Yeah, you're right. Let me clean this up here. It was hard. I didn't give myself enough room in this area. So let me clean this up a little bit. Okay, here we go. Okay, one more time with this. So yeah, I dropped that 0.17. Okay, so I think we're good here. Let's go back to it. Okay, so this was 0.17 right there. And then this was a 0.17 m. And so when we put it on the left-hand side, it's 30 plus 0.17 m. There we go. So then we subtract 30 from both sides, and you get 0.17 m is greater than 20. So we got to divide by that 0.17. Divide this by 0.17. Now, when we divide that by 0.7, we're going to get that number there of 117.6. So I'll check it here. 20 divided by 0.17 is, see, there's your 117.6. Now, what does this stuff mean here? Well, A will be greater than B if you drive 117.6 miles all the way up to infinite. And this is a symbol for infinite amount of miles. Now, the way you type in infinity on MyOpenMath is, I think it gives you that on the space on the thing here. Like when I go here and type in, you see there's an infinity. So the solution to this is any number from 117.6 all the way up to infinity, because, and you got to put that in parentheses. It's an interval is what that is. And that's the way you do that. Because see, plan A, the more miles you drive, the more it costs. But plan B, you could drive to California with that and it's like $50, you know, for the day. Yeah. So plan B is cheaper than plan A if you're going to drive 116 miles, 117.6 miles or more. And that's the way of saying that, 117.6 miles to infinite miles, you know, it's so that's it. All right. So that was, you know, that's a little tough. So there's a lot of stuff here. And so here is 6. So 6, just another algebra topic. It's all over the place here with algebra topics. So the way you do, this is knowing these, it's called rules for exponents. And I'll show you this problem. And it's not a hard problem, but it's one of those things like, oh, well, this is just another fact type of thing with exponents. And that's true. And this is not the type of math that is like kind of common sense math, in my opinion. It's like rules for exponents and stuff like that. That's what this is all about. And I'll show you what I'm talking about here. So the idea with this is if you have exponents, which these are the 3, 3, and 5, raised to exponents like this, the rule is that you multiply your exponents together. So that's real easy to forget this, you know, like if you do this now, or anybody's doing this now, and they're going to take praxis in a week or 2 weeks or a month or later, then you're going to forget this. So this is one of those things that you would have to review before you take the praxis test, just to try to remember it. So you multiply these together. So it's going to be x to the 18th, y to the 18th, z to the 30th. And then in the denominator, same thing, multiply. So it'll be x to the 25th, y to the 15th, z to the 5th. Okay, so see, that's one rule to remember. Now, when you're dividing, what you do is you say, where's the most amount of these and how many more are there? So like, for example, looking at the x's, there's 25 x's multiplied together on the bottom. That's what x to the 25th means. 25 x's multiplied together. X to the 18th means 18 x's multiplied together. So where's the most amount of x's? Down in the bottom. How many more are there down here than there are up here? Just subtract. And 25 minus 18 is 7. And that's why the x to the 7th goes on the bottom. Does that make sense?
Yes.
That's how it works. Same thing going on here. There's 3 more y's on the top. You just subtract, but you put your answer where the most amount is. 18 minus 15 is 3. Well, where does the 3 go? It goes on the top because that's where the most amount of y's are. Same thing here. It's going to be a z to the 25 on the top. And that's the answer. That's how you do it. Yeah.
Okay.
So it's not a hard thing. It's just, wow. It's just
remembering.
Yeah.
Remembering what to
Remembering.
do.
Yeah.
Remembering the formula.
Yeah. The rules. These are, they're called exponent rules. Yeah.
Right. Remembering.
Yeah. And then I'll just show you a real quick one. If you ever are multiplying here, I'll show you a little quick one here that's not up there. If you have 3x cubed, this one gets people a lot, times 4x to the 4th. And I'm doing this particular problem because this really shows it. So this one you're multiplying. So the rule is when you're multiplying, you see when you divide, you subtract them. You know, 25 minus 18 is 7. That's why there's 7 there. When you multiply, you add your exponents. So this is going to be x to the 3 plus 4 is 7. Now, what people want to do is say, oh, well, 3 plus 4 is 7. That's the rule for exponents, not for numbers. Numbers, when you multiply, see, these are numbers. 3 times 4 is 12. So that messes people up a lot because there's one rule for exponents that when you multiply, you add them, but multiplication of numbers, you just multiply it. So these are numbers. When you multiply them, multiply them. But these are exponents. When you multiply 2 things together, you add your exponents. And you know, that's all of the rules for those things. I guess there is one other rule, and that is that anything to the 0 power is 1. That's the 4 rules for exponents. Anything to the 0 power is 1. When you multiply, you add your exponents. When you divide, you subtract your exponents. And when you have exponents, raise the exponents, you multiply. That's, you know, that in itself is one whole day in college math courses right there. And for kids, that's a week, you know, of math. When I say kids, I'm talking about high school kids.
Yeah, definitely.
Yeah. Yeah. Okay. So 8. So you're going to see a variety of topics here. And these are ones that, you know, you don't kind of memorize, these are ones that you kind of study for when you take the praxis test. So what you do to get, you might say, well, why don't you just hit this in on your calculator? Well, when you hit square roots in on your calculator that don't give you an exact answer, there are approximations because there are decimal points that go on forever. So what can you do on that? Well, you can simplify it by breaking it down. And I'll show you an easy one before I do this one. What you do, like, here's an easy one. Square root of 8. What you do is you break the number down into its primes. And so 8 is 2 times 2 times 2. And what you do, so this is another one of these math things, for every pair of numbers, you take 1 out of the radical. So that gives you 2 square roots of 2 is the answer. And the reason is because really when you have a pair of things in here, you get a perfect square. Like right there, 2 times 2 is 4, and the square root of 4 is 2. That's why you can take it out. So this one, you got to break it down into its primes. So what I mean is this is an even number, 294. So let me break it down here a second. 294, 2 goes into 294 147 times. What I did there is just 2 goes into 2 1 times, 2 goes into 9 4 times with 1 left over, and 2 goes in 14 7. Now what goes into 147? Well, 2 doesn't, but I see that 4 and 7 is 11 plus 1 more is 12. And since 3 goes into 12, 3 will go into this. So let me take 3 into this number. 3 goes into 14 4 times, 2 left over. 3 goes into 27 9 times. 49 is a perfect square. It's equal to 7 times 7. So at this point, this is what's underneath the radical. You could save time and not even write that down. But underneath this radical is a 2 times 3 times 7 times 7. Well, just like I say, you look for pairs of numbers. we got a pair of 7s. So that can come out of the radical, and left inside the radical is still the 2 times 3. But that doesn't simplify. So it's just 7 times the square root of 6. And that would be the answer. So the number on the outside is a 7, and the number on the inside is a 6. And that's how you get non-approximated square roots. And that's what that's about there. Yep. So, this is, like I say, this is a hard homework assignment. I guess that was problem 8 there that I did. Why do I have 7 written down?
Well, can you do another one in 7 and show that again?
Yeah. Actually, this problem was problem 8. And I'll do
Right.
another one like that. Let me see what happened to 7. Oh, 7. I skipped 7. I'll
You
go
did
back to. No, I don't think I did this one. No, I'll go back to 7.
Okay.
But let me do another one like this one. So, and I don't think you have numbers quite as large as that on the praxis. So let's do one like this. How about, here's another example of breaking down a radical like that. Let's say we have the square root of 72. Well, that's not a perfect square. Like 8 times 8 is 64. 9 times 9 is 81. It's not perfect. So you got to break it down into primes. So what I do is first I see that it's even. And I say, okay, well, 2 goes into 72. 2 goes into 7 3 times with 1 left over, and 2 goes into 12 6 times. Well, 2 goes into 36. Let's do that. 2 goes into 36 18 times. Still even. 2 goes into 18 9 times. And then 3 goes into 9 3 times. While this is algebra, you can see why kids like in elementary school, knowing how to break down numbers into their primes, and they do that in elementary school, is just factoring a number down. That's important because you can't do this algebra topic unless you know how to do that. So in other words, 72 is equal to 2 times 2 times 2. Here's your 3 2s. Times 3 times 3. You could have also thought, well, 72 is 9. See, 3 times 3 is 9 times 8. And here's your 8. Now take out 1 for every pair. So I'm going to take a 2 out of the radical. And I also have 3, pair of 3s. So the only thing left inside the radical is a 2. So the answer is 2 times 3 is 6. Square roots of 2. And that's the answer to that problem right there. If you're wondering, what is the point of this? Well, see, if I hit, I'll show you what I mean. If you hit, see this stuff, if you're doing real like engineering and stuff like that, you don't want to have an answer. And I'll tell you why you don't want to have this. Like if you do this on a calculator, it's not helpful. I'll show you. Square root of 72. And you get this answer. That is not the exact answer of this, because radicals like this go on forever. So this is 8.485281374, but let me tell you what, it goes on forever. Then if you use this to say, okay, this is what the size of this rubber gasket needs to be on the space shuttle or whatever it is, when you do this, even though it's this exact, then when you have to multiply this number by something, then you have to do more calculations to this. This rounded number, it keeps on getting more and more off from the accurate number until you are off by 1/10 of an inch. And then at that point, it's like, it is way off and you're going to cause recalls to that thing or cause malfunctions. So instead of doing that, what they do is they simplify it down to that. And then the further calculations they have to do on that will be done with this non-approximated thing right there. See, if I take 6 times the square root of 2, 6 shift square root of 2, guess what I get? The exact same decimal. But they don't want to use the decimal because that's an approximate number. So anyway, that's the point of it right there.
Okay.
Okay, I'll tell you what, I will go back to 7 in a little bit. That's on factoring, and that's a big topic here that's going to come up. So I'd rather go back to that when we get to that. I feel like it's a little out of place. This question 9 is more like, see, radicals, more stuff like that. Okay, so there is, a thing in math. You know how in English they say, don't say ain't, and you shouldn't do this and that in English, right?
Right.
Well, this is one of those things in math that they say you should not leave radicals in the denominator. It's called an improper way of leaving things. So I'll show you this without any junk on the top. First of all, let's say we had 1 over the square root of 5. Well, that's an improper term in math. The way you clean up that improper term is to do this. You multiply the top and bottom by that number. And it's okay to do that because anything over itself is 1, and 1 times this stuff is this stuff. So it's just another way of saying this number without leaving it in this. It's called a radical in the denominator is not appropriate or whatever. You know, just like things saying certain things in English aren't appropriate or whatever you want to say. You know, it's just one of those things.
And not a good teaching model either.
Right. So you don't want to have proper papers written with certain things like ain't and blah, blah, blah. So I don't really think it's an important topic because this number here is exactly the same value of what I'm going to end up with, but the form that I have it in is the more proper form. So all you do is this, multiply by whatever is down here. So 1 times the square root of 5 is square root of 5. And the square root of 5 times the square root of 5 is 5. Why? Because square root of 5 times the square root of 5 is the square root of 5 times 5 is 25. And the square root of 25 is 5. So what this does is it eliminates the radical in the denominator. And so you can just bang, you got the answer. And I guess another reason for having this is when you're dividing by a radical, that's if you would do this on a calculator, this round off buildup is going to take place because now you're dividing by an approximation. Blah. And if you ever take trig, there's like some of your students might go on to take trig. And I know, first of all, they're going to take algebra and do this stuff. And in algebra, they're going to say, well, why am I doing this? Well, it's a proper form and all this stuff. But it's also when you're doing trig, you learn things like, well, the sine of pi over 4 is equal to the square root of 2 over 2. See, they have it this way. Square root of 2 over 2 is how you learn that. You don't learn it this way, 1 over the square root of 2, even though these two things are exactly the same. So I'm just saying it comes up. Even a weird thing like this comes up. All right. So now we're into the big stuff. So now we're into factoring. So I'll go back to that problem 7. And let me tell you this factoring stuff, what you're going to be doing factoring is, it's not just factoring numbers like 8 is 2 times 2 times 2. This is factoring expressions like ones you'll see down here. So I'm going to go back, and boy, they spend a lot of time with this in algebra 1 even, and algebra 2. And I think there should be less of this done in math courses, more problem solving. And in fact, some people have said, you know what? If you do the problem solving, people can pick this stuff up because this is the stuff, everything I'm showing you here is stuff that people learn. And guess what? They forget. And it's true. But you know, if you become good at problem solving, then that kind of is something that helps you in all your courses. So that's why I think that's a more important topic. So anyway, here back to 7. See, it says factor. So factor is kind of like breaking things apart. Is there a common factor is what we're looking for. So this is what we're going to factor here. 2w to the 6th, x to the 4th, plus 8w to the 9th, x to the 10th. I think people sometimes when they're taking math are thinking, well, this has got to be, it looks horrible with all these letters and numbers and exponents. But really what you're doing with these things is just looking for something that's common. So first of all, you got to look at this as being two things. There's this term and this term. And you say to yourself, what's common on this? Well, I tell you what, let's start with the numbers first. The common factor is the biggest number that will go into both 2 and 8. And people will often say, well, isn't that 8? 8 doesn't go into 2. But let me ask you this. Does 2 go into 8?
Yes.
Yeah. And you can't go any bigger than the smallest number. So the common factor in terms of the numbers is 2, because 2 will go into 2 and 2 will go into 8. And we're going to be doing plenty of these. So if you're not sure yet, don't sweat it, because you're going to see a lot more. Now, just like the most common number here is the smallest number, it's not always the smallest number when it comes to your numbers. Your numbers are the harder thing. It's called the greatest common factor, which actually is a small number. But 2 goes into 2 and 2 goes into 8, and you can't go any bigger than that because that's as big as that goes. Well, the greatest common factor in terms of the W is what's common to both. And what's common to both is actually the W to the 6, because there are 6 W's here and there's 9 here. I can't factor out more than 6 because there aren't more than 6 here in this one. You can't factor out more than you have in any one term. Does that make sense?
Yes.
So the greatest common factor for the X's is going to be X to the what?
X to the 2, 6, 4.
So is it going to be 4 or 10?
It's going to be 10, isn't it?
Well, look at what we did with the W's. Was the
Right.
greatest? It was the smaller one, right?
Yes.
And so that's what's going to be here. It's going to be X to the 4th,
Right.
because you can't take 10, factor that out, because you don't have 10 here. You don't have 5, 6, 7, 8, 9, or 10 here, but you do have 4 here, and you definitely have 4 here because you have 10 of these. So you definitely have at least 4 of them here.
Got it.
Now
Got it.
that
Okay, I see it now.
Now that's your greatest common factor. Now you factor that out. Factoring out, when you say factoring out, it means exactly dividing out. They mean the same, but dividing out helps remember it better, because now what we have to do is think, if we take this whole thing, so we do it one at a time. If we take this thing right here and divide it by this, you get 1. The reason you get 1 is because this is exactly this. Just like 5 over 5 is 1, and x squared over x squared is 1, because it's the same stuff. If you have 2w to the 6 x to the 4th over 2w6 x to the 4th, it's exactly the same.
It's 1. Yeah.
It's 1. So now let's go over to this one. So take it piece by piece here. 8 divided by 2 is 4. Okay with that so far?
Yeah.
Now, you might say, well, do I do the 9 divided by 6? No. And the reason is because these are exponents. So if we have w to the 9th over w to the 6th, you actually get w to the, do you want to try that? What do you get?
So you're factoring down, right?
Yeah.
So it's 3.
Boom. Very good. So that's going to be w to the 3rd. And by the same idea, this is going to be x to the
So it's either to the, because we're factoring down, so it's going to be x to the 5th or the 2nd.
well, look, how did you get the 3 here? We thought that's w9, w to the
Right.
9th over w to the 6th.
That's right. So it's going to be, so we have 5, there are 2 5s and 10, so 2. So x to the 2nd.
Well, let's look at this. How do we get the w to the 3rd? We subtracted. We took
That's
9
right.
minus 6. So now
Right.
just do 10 minus 4. So it's x to the 6.
X to the 6. Okay, I got it.
And look, if I click on here, you'll see that's the answer. See, 2w
Yeah.
to 6, x to the 4th one. It's exactly it.
I
So
got
that's
it.
how you do that.
Okay.
And it might be worth it to do one more of those. I'll scroll
I
down
was
here.
thinking in that, because we did subtract with the W's, so we do the exact same operation. Okay, with the
That's it. That's it. I'll do one more. That was a pretty messy one. But
Okay.
you'll see them that messy. So here's another example of that. Let's say we have something like this, real similar. Let's keep it about the same level. So let's say we have, I don't know, how about this? 12x cubed y to the 5th minus, let's do 30 x to the 6th y to the 3rd. Okay, so now we're going to factor this. That's what we're going to do with this, factor it. So we say, so we start off with the numbers. What is the greatest common factor between 12 and 30? What is the biggest number that goes into both of those?
6.
6, right. And you can see that's an elementary school thing, kind of where they start to learn about multiplication, like what's the biggest number that will go into two. So it's a little bit of thinking stuff there. And then now, what's the common amount of x's we have? X to the what power is common? And I'll use the example up above to show it. So look here with this one, it was a w to the 6th and a w to the 9th, and the common was w to the 6th. So x cubed, x to the 6th, what's common to both is x to the
3rd.
right. And then it'll be y to the what? What's common? This is y to the 5th, y to the 3rd. So the common factor, what's common, is y to the
Would it be? So we're going to subtract.
So no subtracting yet. This is just looking what's common. Like up here, W6 was because 6 was the lowest amount of W's.
Right.
X to the 4th because 4 was the lowest amount. 3 here. So there's going to be y to the.
So the common number would be 2.
It's just the lowest amount of y's. So there's 5 here, there's 3 here, so it's y to the 3rd. So that's how you get your common factor. Right. Okay, so now this is where when you take factoring it out, that means dividing out, that's where you do this. So, okay, so the one we did before, the first term was completely factored out, but that's not the case here. So we say, okay, 12 divided by 6 is 2. Then we say, how many extra x's do we have here? None. No extra x's. X to the 3rd, x to the 3rd. How many extra y's? 2. So we put the 2 right up on top. Then we go over here and we say 30 divided by 6 is 5. Then how many extra x's do we have here? Well, here we have 6. Here we have 3. So that would be 3 extra x's.
Right.
And then how many extra y's here? Well, here we have 3. Here we have 3. No extra y's. Boom. That's it all factored down.
Okay.
That's how you do it. Yeah. That's called factoring out right there.
Okay.
This one is really not worth doing. I mean, this is just from a formula on 11. I probably should just get rid of this problem. But I actually did see it on the practice test. I think it's horrible. I wonder if they put it on the real practice test. I can't believe they do that. But I'm just going to show you the answer. It doesn't change. It's a formula, and it says this. So this just comes from a formula. It's called the quadratic formula, and this is underneath the radical. So square roots have to be, the numbers inside of square roots have to be positive. So this says what number must be greater than 0. In other words, positive. So anyway, this is the answer to 11. I think I'm going to remove this problem next year to get that out of there. So you can just write that down. That's the answer to 11. Yeah, that's all there is to it. It's not a very good problem. But starting with 12, you have more, you're back to factoring. But this is a different level of factoring. So I'll show you what I'm talking about here on this. So 12, okay, here's the way 12 works. So let me write down the problem. And there's one thing that comes up on this topic of factoring is that you can work with young kids to get them to work with the thinking that is involved in factoring. I'll show you what I mean. So this problem has to be done in pieces. You can't cross off this x squared with this x squared because these things are added or subtracted together. The only time you can cross things off is if they're multiplied together, not added or subtracted together. So you can't just cross off a piece, and that's what people like to do. What you have to do is switch this to things that are multiplied together. Well, to get these to be things that are multiplied together, you have to factor this thing. So I'm going to factor each one of these things, the top and the bottom, separately. So here's the top, x squared minus 4x plus 4. So we're going to try to factor this thing. So the first thing you do is you look to see if there's a common factor. Like, there's 3 terms here, and do all 3 terms have a common factor? They don't, and I'll tell you why. You might say, well, do they all 3 have an x? No, they don't. This one doesn't have an x. Do they all have a common factor of like 4 or 2? No, they don't, because this doesn't even have a 2 or a 4 in front of it. So they don't factor out. So this thing is called a trinomial. A 3-term thing is just called a trinomial. If it does factor, it will factor into 2 binomials, which means inside of these things, inside these parentheses, will be 2 things like x plus some number or x minus number, and over here will be the same type of thing. So I'll show you how this works. This x squared comes from these 2 things multiplied together. So the only thing that will give you x squared is an x times x. So right here is an x and an x, because x times x is x squared.
Right.
So no problem with that. So now you play this game that you could even play with young kids that know multiplication tables, like, I don't know, 3rd or 4th grade. So you say this, factors of this. So you say, now they wouldn't have negative numbers like we're going to have on this problem, but positive numbers you could do. So you say factors. And when you say factors, you say, really what that's saying is numbers that multiply together. So when you say factors, it's numbers that multiply together to give you this number, positive 4, that add up to that number, negative 4. And they're kind of hard to think of, but if you think of them, you got the problem. So now you have to think of numbers. So when you say factors, it means numbers that multiply together to give you 4. So give me 2 numbers that multiply to give you 4. 2 times 2, right?
Yes.
But does 2 plus 2 add up to negative 4? No, it doesn't. But can you think of 2 other numbers that will multiply to give you 4? And maybe they're negative. So I'll give you a hint with this one. You got to think negative numbers too. For example, negative 2 times negative 2 is 4.
Right.
Because 2 negatives. And what is negative 2 plus negative 2? Negative 4. So your answers are negative 2 and negative 2. And that's the way you factor these things down. So that's what the top one is going to be. X minus 2, X minus 2. Now I know that was the first one, but I tell you what, after doing a few of these, you get better at it. Let's try the bottom one. So let's try to factor the bottom part here. Factor this thing. So the bottom thing is this, x squared minus 5x plus 6. So what you have to say to yourself is this, numbers that multiply, the factors of means multiply. So two numbers that multiply to give you 6, they multiply together to give you 6, but they add up to negative 5. So there's going to be something negative here on this. 2 numbers that multiply to give you 6 that add up to negative 5. It can't be 2 times 3, right?
No, because that doesn't give you negative.
Right, because 2 plus 3 is 5.
5, right.
Right, but it's supposed to be negative 5. So instead of being 2 times 3, it needs to be what?
2 times 2 times -4.
Well, 2 times -4 is -8.
Right.
But if you're thinking, thinking
negative
3,
3.
2 times -3 has one negative, so that'd be -6. But
Right.
we need this to be a positive. So the only way this is going to be positive is if they both are negative. You know what I mean?
Yes.
-2 times -3 is +6.
It's +6. Yeah.
And -2 plus -3 is -5. And that's what we want. We want this to be 6 and this to be 5. So in other words, this thing right here breaks into x minus 2, x minus 3. So you just put those right after the x's. So I'll go up here and put them in. So right up here on the bottom is what this x squared minus 5x plus 6 broke into, which was x minus 2, x minus 3, because that's what it factored into. Now, since these are things multiplied together, you can cross off BIP with BIP because they're like terms. You could have crossed off this with this, but one of these with one of these. Now it's completely simplified. So this is basically saying this F thing is on the top. So what is your answer for the top? Here it is, x minus 2. Bang. And then what's the thing on the bottom? It's going to be x minus 3.
-3.
Yep.
Yeah.
And that's how you do those. This one, I think you just get credit for, well, no, you have to do this. Watch, well, there's actually gives you a problem with it. So you can watch the video, but let's go ahead and do the problem for practice. And all I can tell you is these are not easy. They, you know, but you have unlimited amount of time and you have all that stuff there to work on those. So this is problem number 13. We'll give it a shot. Yeah, so this one is 4y squared minus 12y plus 9. And we got to factor it. So you look for a common factor. Well, there's got 3 terms. They don't have a common factor that will factor out. So if you're thinking, well, do they all have a 2 will go into them or a 3 or anything? No, they don't. The only thing that goes into 4 is 2, and 2 doesn't go into 9. Do they all have a y? No. So there's no common factor. So what can you do here with this one? Well, you can do this stuff that we did before. This one's a harder one. So what you do here is you say 2 numbers multiplied to give you 4 is 2. And 2 things that multiply together to give you y squared is y. And if you think about this, 2 times 2 is 4, and y times y is y squared. Okay. Now, there's no easy way of doing these. This is called, the method of solving this is called trial and error. The only thing you can do is try something, see if it works. If it doesn't work, try something else. So now what we need, just like up here, we said 2 numbers that multiply together to give you the 6, like that number right here. That's all the farther we can do with this because of this extra stuff here. So all we can do is say, let's try 2 numbers that multiply together to give me 9. Okay, so you try factors of 9. So give me 2 numbers that multiply together that give me 9. You can't even use the 12 on this because there's this extra thing here. But there aren't too many numbers that multiply together to give you 9.
Right.
So 3 times 3. So that's exactly the thing I want to try, 3 times 3. So you put, and those are positive 3s. So I'm going to put a +3 here and a +3 here. So I'm going to show you now how you check this. And I'm going to need to do this down below because I wrote this try factors of 9 here. So here's how we're going to check this. This may or may not be right. You have to try it and see if it's wrong. If it's wrong, try a different number. If it's right, you're done. So this is how you check it. We already know that 2y times 2y is 4y squared. So we don't need to check that. We already know that 3 times 3 is 9. So we don't need to check that. What we have to do is check and see if we get this number, this minus 12y. And the way you do this is you check your inner and outer, and see if they add up to this. So 3 times 2y is 6y. 2y times 3 is also 6y. And then you add these. 6y and 6y is 12y. And you might say, yay, we got it. We didn't. We came real close. This is a positive 12y, but we need it to be a what?
Negative 12y.
That's easy to fix. So if you ever miss it by a sign, like it needs to be negative, then just change your numbers inside.
-3.
Negative, and
yeah, 2y, -3.
that's it. And that's the answer to that problem. I'll click right here and show you. Boom. That's it. They just wrote it with a square there because anything times itself is squared. Now, this is the same type. You know how we were thinking, give me numbers that multiply together, that give you 8, but they add up to 6. So this is the type of thing that you can ask kids, and it will really help them when they go on to algebra. So this is the fundamental thing that we're doing with this without algebra. So this says find 2 integers, but really we're just meaning whole numbers. What 2 whole numbers add up when they say sum? That means add up to 6.
Yes.
But they multiply to give you 8. Can you think of those 2 numbers?
2 and 4.
Done. 2 and 4. You just list them there with a comma in between. And that's the type of thing. Guess what? You can ask young kids that when they know their multiplication tables, and it will help them. Like we used to, when we were driving on trips or whatever with our kids, when they were down in elementary school, we would say, give me 2 numbers that multiply together. So I'll just show you what I'm talking about because it could be harder problems. 2 numbers that multiply together to give you 56, but they add up to 13. And you think for a while, and you might think, I can't think of that. I made a mistake here. They add up to 15. Sorry. So what?
7 and 8.
Boom. 7 times 8, that's 56.
Exactly.
And 7 plus 8 is 15.
15, right.
And that's because what do you have to know to do this? You have to know multiplication tables. Plus, you have to be thinking about 2 things at the same time. I'll show you what I mean. That one is just a multiplication fact. But maybe you had to think of this. 2 numbers that multiply together, they multiply to, let's say, 30. And they add to 17. So what would that be?
30.
They multiply to 30, 2 numbers that multiply to 30 and add to 17.
Well, I know that 5 and 6 multiply to 30.
But 5 and 6, it's not 5 times 6 does give you 30, but 5 plus 6 is 11.
Only 11.
So that won't do it. So what other 2 numbers will multiply to give you 30?
3 times 10.
Well, 3 times 10 works there, but 3 plus 10 is 13. So can you come up? So you have to keep on trying to come up with numbers.
So it's 2 times 15.
That works. 2 times 15 is 30, and 2 plus 15 is 17. And see, that's the type of thing that helps. Young kids can do this, and it will help them in algebra because this is the algebra problem that goes with it. X squared plus 17x plus 30. And see what you would do. It's easy to know that, okay, this is a trinomial. It breaks into 2 of these. The x squared breaks apart into x and x. And now you say to yourself, numbers that multiply together to give you 30 that add up to 17. 15 and 2. And it doesn't matter if you put the 2 there or the 2 there. If you put the 2 there, put the 15 there. But boom, you get your algebra right. The hardest part with the algebra is doing the arithmetic. And a calculator doesn't help you because you can't say to a calculator, hey, what 2 numbers multiply to give you 30 and add up to 17? You can't. You need a human to do that.
Right.
So, yeah. So don't want to do this one. This is an easy one. The only thing that factors down is this one, but we can do it if you want. I'll tell you what, well, let's do 2 problems and we'll see how you feel. And if we want to stop there, we can always pick up on this. We know we got some extra time in the
Okay.
class. So let's do 15 and 16 and we'll call it. So 15 is this one, x plus 2 over x squared minus 2x minus 8. And this says divided by x minus 1 over x minus 4. Now, the very first thing I want to do with this is you have to know that when you're dividing by a fraction, it's the same as multiplying by the reciprocal. So in other words, you change this to multiplication and you flip this. This is x minus 4 over x minus 1. And see, that might seem like something new, but when you say to somebody in basic math type of thing, what is 1/2 divided by 2? Well, you have to flip that, see? 2 is 2 over 1. So that's really says 1/2 times, flip that, 1/2, which would be 1/4. So if you know this fact, that when you're dividing by a fraction, you multiply with reciprocal in basic math, which you learn in like 5th grade or so, then the algebra, you say that's not a new thing for you. The only new thing for you is the factoring. And the hardest thing with the factoring is, again, the basic math. So things like this little thing, that doesn't factor. There's no common factor. It's not a trinomial. It's not to the 2nd power or anything like that. So there's nothing that happens with that. Same way with these 2 over here, the x minus 4 and the x minus 1 are just, they don't break down. There's nothing to break down with those. So the only thing that we have to break down on this problem, it's a pretty easy problem, is just this little thing here, this x squared minus 2x minus 8. So just down below here, I'm going to factor this thing down. So it's a trinomial. There's no common factor. There's not like a 2 that goes into all 3 terms or anything like that. The x squared breaks into x and x. And now you play the little number game. You say 2 numbers that multiply together to give you -8, and they add up to -2. And you can see that knowing your negatives and stuff, that's critical. So 2 numbers that multiply to give you -8, it could be -8 times 1. It could be other things, but you get a negative when you have one negative times a positive. So for example, -4 times 2, that is -8. And if you check that, -4 plus, see, to add them together, -4 plus 2 is -2. So that's your winning numbers there, -4 and 2. So that's what that breaks down into. When I say 2 here, that's +2. And that's it broke down. So here I'm just going to put x minus 4 and an x plus 2. Now at this point, everything's broke down, so you can actually cancel out these terms. So this x plus 2 cancels out with this x plus 2, and this x minus 4 cancels out with that x minus 4. So when you cancel out, they really divide to 1. What you're saying is x plus 2 goes into x plus 2 1 times, x plus 2 goes into x plus 2 1 times, x minus 4 goes into x minus 4 1 times, x minus 4 goes into x minus 4 1 time. So 1 times x minus 1 is x minus 1. And on the top, 1 times 1 is 1. So your answer is that right there, 1 over x minus 1. And you can see, boom, that's what you get. So let's do 16 and we'll wrap it up with that. So 16. So here we go with 16. And that looks like this. So I'll write down x squared plus 9x. Now, if I was doing this on the praxis test, I'll do it like I was going to do it on the praxis test. I would not rewrite this problem exactly like it is, because the very first thing I see is that there's a division. So I'm going to say multiply, and I'm going to go ahead and flip it. X cubed plus 3x squared. I'm not going to waste time writing this problem down because I can see it right there. You know, I don't have to write it down. So I'll just take care of the first step, which is easy enough flipping it. Now I play the factoring game. So up on the top, the x squared breaks into x and x. And I'm getting used to this. You get better and better at this. You say 2 numbers that multiply to give me 8 that add up to 9. Can you think of that? 2 numbers multiply together to give you 8 that add up to 9.
Times 1.
Done. 8 and 1. Very good. 8 times 1 is 8. and 8 plus 1 is 9. Boom. The x squared doesn't break down. It's not a binomial, like it's not two terms or anything. There's nothing you can do with that. Over here, this one does have a common factor. Here, I'll do this one. It's a little bit harder. So both of these on the right, especially the top one's a little bit tough. So this is just my scratch piece of paper here. So the first thing I noticed with this x cubed plus 3x squared minus 4x is that it does have a common factor. Each one of these three terms here has an x. So I can factor out the x, and when you factor out, you're dividing it out. X divided out of x cubed is x squared. It just knocks it down one. X out of this knocks it down one. I'll take it down to 3x, and the x out of here takes this one x out, taking it down to just minus 4. I just reduced, since I saw that there was an x, I took it out, and that knocks each x down one power. Knocks it from 3 down to 2, 2 down to 1, and 1 down to none. Now I need to re-break down this thing. That's a trinomial that breaks into the two parentheses. The x squared breaks into x and x, and now you play the game. You say two numbers that multiply together to give you -4, and they add up to 3. So think of numbers. See, if they multiply together to give you -4, that means one of the two numbers is negative. So numbers that multiply together to give you -4. What are you thinking?
-2 times -2.
Well, -2 times -2 is +4, but you could do -2 times +2. That will work. But does -2 plus 2 add up to 3? -2 plus 2 is 0. So that doesn't work. So we got to try two other numbers that multiply together to give me, so I'll just write it down again. Two numbers that multiply together give me -4 and add up to, add up to 3. So what other two numbers can multiply to, well, don't even think about the negative. Besides 2 times 2 to give you 4, what other two numbers multiply to give you 4?
4 times 1.
4 times 1. So one of those have to be negative to give you a -4. So how about
-1 times 4.
let's do that. -1 times 4. Now check it and see if it adds up to 3. What is -1 plus 4? -1 plus 4 is 3. So you got it. Now, if you ever check this, you could have said 1 times -4, and then 1 minus 4 is -3. If you ever miss this by the sign, all you do is just flip-flop the sign. So we know that these are my factors, -1 and 4. So that's -1 and 4. So this whole thing is what this x cubed thing breaks down into. So this thing right here breaks into x times x minus 1 times x plus 4. We got one more to break down, and that's this x squared minus 1. So let's do that down here too. That's a weird one. So looking at the x squared minus 1, here we go. So what I'm going to do with this is write it this way. I'm going to say that is exactly the same as x squared plus 0x minus 1. See, all these that we've been factoring have been 3-term things. See, 3-term thing, 3-term thing. This one, a 3-term thing, 3 terms. So if there's not a common factor, if you have something squared, it might break down even though it's 2 terms, but to know it, you want to write it as 3 terms to help you break it down, like an x squared, an x to the first power, and then the number at the end. Now, where there is no x to the first power, that's why I put a 0 there.
Okay.
So now what we do is this, we play the same game. So x squared breaks into x and x, and now we need factors, things that multiply together to give me -1, two numbers that multiply together to give me -1. that add up to 0. So what two numbers multiply together give you -1?
-1 and negative.
It can't be two negatives. Two negatives multiply to give you a positive. So -1 times what?
+1.
Right. -1 times 1 is -1. That works. And what is -1 plus 1? 0. You got it. So this is going to be x minus 1, x plus 1. So that's what the last one breaks into.
Okay.
So let's put it right there. So this x squared minus 1 breaks into x minus 1, x plus 1. And now we just have a bunch of things multiplied together. So what you do is just now you can cancel things out. Anything on the top, which is in the bottom, you can cancel it out. So I'm seeing here's an x plus 1.
Yeah,
And,
right.
in that one. And then here's an x minus 1. I can cancel that out with this. There's one more thing you can cancel out. X squared is really just x times x. And I see that here's a solo x up here too. Like I can't cross this x out with this x because this x is part of this binomial right here, x plus 4. So I can't do that. But I can cross one of these x's out with this x here. It's a standalone x. So it's a lot of mess right there, but what remains? Well, up on the top, I have an x plus 8 and an x plus 4, right? On the bottom, I just have an x. And so guess what? That is the answer to this problem right there. So if I click on here, look, you're going to see that is the answer. X plus 8, x plus 4, bingo, over x. You know, it's a long problem. And then just to finish this problem off, it says, what restrictions are there? Well, this deals with any number that would make the denominator equal to 0. So I'll show you. It's kind of rough. So I'll show you. It only take a second. I know it's getting close to that time. So looking at this problem up here, look at what the denominators are. There's an x squared. I'll list them here. So this is talking about the restrictions. For the restrictions, you look at the denominators. We had a denominator of x squared. The only thing that makes x squared equal to 0 is if x equals 0. The only number squared that equals 0 is 0. So that's all there is to that. The other, there's another denominator up here of, and here's the factored form of it. It was x minus 1, x plus 1. So I'll list that here. It was x plus 1, x minus 1. What makes that equal to 0? Well, you look at each part. What number plus 1 equals 0? Well, that would be -1. -1 plus 1 is 0. What number minus 1 equals 0? Well, that's +1. So far we have 3. Now this, what we have to do is watch out for things in the denominator. And you might say, well, that's all the denominator there were right there. There was an x squared. See, the x squared and the x squared minus 1. But the original problem also had this as the denominator. So we also have to watch out for the original problem that had the x cubed thing. So that x cubed, that denominator of x cubed plus 3x squared minus 4x, that's the one that broke down into this whole bunch of junk, right? Where was it? Right here, x minus 1, x plus 4. So I'm going to write that down here. X, it was this, x minus 1, x plus 4. Well, what makes these equal to 0? Well, that's just a standalone x. The only thing that makes x equal to 0 is 0. What minus 1 equals 0? Well, that'd be 1. And then right here, you say, what number plus 4 equals 0? That'd be -4.
Right.
Right. So putting it all together, we have from this one 0, 1, and -4. From this one, we just have, from this x squared one, we just have 0, which we already have. Then from this one, we have -1 and 1. So the new one there from this one is -1. So the listing of restrictions are these numbers: 0, 1, -1, and -4. You don't have to list them in any specific order, and I'll show you that that's the right answer. -4, -1, 0, and 1, and that's all of them. And the restrictions is that the X value, X cannot equal these things right there, because that gives you division by 0. So I'll stop it right there. That's some pretty high powered math. And we'll pick this up on next week then.
All right, then, thank you.
Thank you. Okay, bye-bye.
See you later, bye-bye.